Hello, everyone, and welcome to today's webinar by GreenTech Media. Today's presentation, How AI is Improving the Customer Experience in the Energy and Utilities Industry, is brought to you by our partners at SparkCognition. My name is Fei Wang, and I am a Senior Research Analyst at Wood Mackenzie Power Renewables, formerly GTM Research. I cover customer energy management on the Grid Edge team, and I'll be moderating today's webinar. We have two great speakers today to dig into this topic, how artificial intelligence can be a powerful tool in improving customer experience. Jessica Hamm is the Director of Solutions from SparkCognition, and Rodney James is the Technology Development Manager at Duke Energy. And if you're interested in upcoming events hosted by GTM, please feel free to take advantage of the discount code webinar for a 15% off. And before we get started with the presentation, I'd like to take a moment and go over the screen in front of you. Speaker bios are now accessible from the top tabs by clicking on each speaker's name. And you can also use the link on the left-hand side of your screen to download a copy of today's slides. Most importantly, please note the Q&A module on the left side of your screen. And at any time during today's presentation, please submit your questions for our speakers. We'll have about 10 minutes at the end for a Q&A session. And if you don't get to all the questions during today's an hour, we'll follow up offline. And I'll kick off today's presentation with a quick glance on the state of customer experience at energy utilities. So, all right, let's get started. And so last year, GreenTech Media conducted a survey asking utilities, as changes are happening at the grid edge, what are they thinking of in terms of bringing more investment in? And based on the survey results, customer engagement was the leading answer. And there are a couple of factors that will play into this survey result. One is customers are turning into more grid interactive assets with emerging technologies rather than passive load as they're traditionally considered. And engaging customers and improving customer experience means that utilities can potentially have additional revenue streams through this type of interaction. And secondly, utilities are also facing cost pressures. So to streamline the customer experience and customer interaction means increasing savings for utilities, which is a great thing for them. And to follow up with this particular survey, GreenTech Media and Energy Savvy dug into a little bit more. And we have conducted a survey asking utilities where they think they are in different parts of this improving customer experience. And we have asked them questions about where they are in terms of systems, data analytics, KPIs and measurements, customer engagement, process and operations, brand market management, and people and organization. We also interviewed various utilities executives whose jobs are solely focused on improving customer experience to answer these questions as well. And one thing that was really interesting that came out of the survey is that while utilities are satisfied with the fact that how they can improve their brands, evidenced by higher scores they have scored themselves in brand market management and people organization, the actual core capabilities to process data and conduct data analytics to support further business cases are in general lacking. So that was interesting, meaning that utilities want to do better, but the actual abilities are not there yet. And this is where today's presentation will be focusing on as well, how AI can be a powerful tool in helping solve these issues. And one area that received a lot of attention over the past few years where utilities have deployed advanced analytics abilities is outage communication, outage analytics. And this is largely driven by severe weather events. And this is a take-home slide. I understand there's quite a bit of text on this slide. You can dig into the details later. I want to direct your attention to the chart at the bottom of the slide, where post-2011, when storms had been coming more often and more damaging, you see an increasing amount of deployments for utilities to conduct this outage analytics and communication to improve customer experience in this very particular way in both North America and Latin America. So while outage communication is key and important, there are a lot of other use cases in improving customer experience in energy and utilities industry. And as I mentioned before, AI can be a very powerful tool. And so I'll be handing it over to Jessica Hamm, Director of Solutions from SparkCognition, to start her presentation. Jessica, take it away.
Great. Thank you. So thank you for the introduction. Rodney and I are very excited to be here with you today talking about how AI is improving the customer experience. As Faye mentioned, that customer experience encompasses many things. And we'll talk about use cases that range from, resiliency and reliability from a service standpoint to the very unique customer experiences that AI-enabled solutions can provide. So, our plan for today's webinar is organized in 4 different parts. We're going to speak a little bit about the energy and utility landscape and the transformation that's really underway. I'll provide some background on artificial intelligence, kind of an AI 101. We'll discuss those use cases in AI for energy and utilities. They're clearly not all-encompassing, but hopefully there's a few that we can highlight that will get your thinking going on what might be possible for your operation. And then Rodney will provide an overview on some of the exciting work that Duke Energy and the emerging technology team is exploring. So if you've been following GTM, as well as other kind of thought leaders out there, you're probably well aware that the utility industry is in the midst of quite a transformation. It seems like most writers and speakers, they talk a lot about the 3 or 4 Ds. It seems like we see that all over the place. It's decentralization, decarbonization, digitization. You could add things in like decreasing consumption and disintermediation. But it's a challenging time with all of those pieces, and those D words, they really manifest into layers of pressure that you could group in a couple areas, demand and infrastructure. So on the demand side, things are changing, and as Faye mentioned, utilities are having to work harder to remain competitive and meet customer expectations. It's a given that consumers expect more options and personalization. They and we were all used to working with Amazon and other tech companies, and getting utility to that state of engagement can be a challenge given some of the old systems that utilities may still be working with that. On top of that, in some parts of the world and some parts of our country, the customers want and expect more than that one-way relationship. They want to be a prosumer. They want to contribute energy to the grid and change that level of engagement. The investment model is also changing. It requires different types of investments. Utilities are seeing price pressures from regulators and interveners who expect more and different things out of their investment dollars. Rate design continues to be reimagined and innovated as rate makers are looking to create sustainable business models that provide value for the customers, but also for the utilities. New participants are starting to enter these markets. And, of course, there's renewables, there's energy storage providers, but also other service providers that have figured out how to provide an experience that might be faster, different, or just a little more creative than what an energy or utility company was providing before. And that can often lead to a dilemma. Do you compete or do you try to partner? Infrastructure is also pretty ripe for investment. There's a very challenging and complex mixture of old and new systems that can pose some pretty significant integration challenges. And from a customer standpoint, their expectations for reliability and resilience, they just continue to grow. Whether you're a business or a residential customer, I think we've kind of gotten to the point where outages just aren't acceptable anymore. And lastly, while pockets of the country, are seeing some net growth in energy demand, it continues to remain pretty small, and it's, as Faye mentioned, requiring utilities to really think more about that services mindset to drive growth for their business. So in the midst of all of this change, utilities they're overhauling their systems. They're trying to find new ways to create value out of all of this data they've been collecting for years, and we're excited to talk a little bit more about that. Many of the utilities out there have already embarked on this digitization journey and are in a really great position to reap benefits. McKinsey estimates that digital optimization can boost utility profitability by 20 to 30%. That's pretty significant, and it's not easy to get there. It can be a challenge, and thinking of that kind of takes me back to Psychology 101 years ago in college and Maslow's hierarchy of needs. The highest level of need, self-actualization, it refers to a person's full potential and the realization of that potential. And in the case of digitization, truly achieving and boosting that profitability can only be achieved by fully realizing the potential of an integrated system. And that really means applying analytics, applying artificial intelligence to not only make sense of all of the data you're collecting, but to turn that data into actual action. The good thing is, utilities have been at the forefront of IoT for decades. We had connected devices and machine-to-machine communication before those were even buzzwords. That legacy has now been taken to the next level as an abundance of new systems, sensors, apps, tools, they're all being deployed across all parts of the energy ecosystem, in front of and especially behind the meter. Often the challenge that you face now is determining which pieces of data are helpful, what's useful, what should be brought back, what should stay in the cloud, what should remain at the edge device or even at the customer. And there's a lot of data out there and a lot of change that's presenting new and unique challenges, but also a lot of opportunities. A few interesting predictions we found align pretty well to these challenges, and in particular, the opportunities. So the Forbes G2000 is a list of the top 2,000 companies globally. It includes an impressive 117 utilities. And they predict that by 2019, it's expected that 85% of utilities in that list, so that would be about 100, will have established a new business unit with its own financing and governance, or a separate company to speed up innovation and business transformation. If you think about some of the largest tech companies out there, they expand their value, they expand their growth by developing new business units, supporting fast-moving units with dedicated resources. And we're really starting to see the same thing happen in utilities. There's innovation centers popping up, there's venture arms being established, a number of acquisitions taking place and partnerships across the industry. It's leading to a lot of new business units and to new organizations that are dedicated to taking advantage of the transformation that's underway. And in that same context, there's a prediction out there that by 2019, 40% of digital transformation initiatives will use AI services, and by 2021, an impressive 75% of enterprise applications will use AI. So these transformations are happening, and AI is going to be a critical part of this growth. The challenge, in order to make those predictions come true, the new organizations are going to have some pretty far-reaching goals and some long-term strategies. And later today, we want to talk a little bit about a handful of these opportunities that are specific to AI and around improving that customer experience. So AI technology has really advanced over the last few years, and we're at a point where it's time to start actually implementing solutions that will transform their operations, really differentiate the energy product from a customer view, and improve that customer experience. We selected a few use cases that we're going to highlight. They range from grid resiliency and reliability to individualized customer experiences and offerings, as well as resource staffing. But before we dive into the use cases, I want to take a few minutes, as I mentioned, to talk about artificial intelligence and kind of why AI and really why now? So AI has been around for quite some time, right? Since the 1950s when Alan Turing created the Turing test. The technology has certainly seen its ups and downs, especially throughout the end of the 20th century. Even as late as the mid-1990s, we really weren't very excited about AI as something that would, fundamentally change business. We kept running into barriers. Either we didn't have enough compute power or we really didn't even have enough data. But things have really changed in the last few years, and there's 3 drivers that have converged pretty dramatically to advance the science of AI. So first, the immense availability and cost of computing power, it has an inverse relationship. So as the availability of the compute power goes up, the cost has been coming down. And that's a really good thing because the compute power that has been used in the largest AI training runs has doubled every 3.5 months since 2012. So we clearly need that capability. Data. I think we all know data is available, seems from everything and from everywhere. So it's available at scales that we've really never seen before, particularly as more IoT devices and other services are getting deployed. We've seen some pretty major breakthroughs in the science of AI. There have been pretty significant advancements over the last 5 years in applying algorithms in an environment that has that immense data and available computing power. So the results and the solutions are impressive, and we're seeing AI, exceed the capability of human or statistical and physics-based approaches. So other forces have really set energy companies and utilities up to make similar significant strides. As I mentioned, utilities were at the forefront of IoT implementations as we kind of sought to manage assets across this huge ecosystem from generation to the customer. So now is really a great time to start leveraging all of the existing and growing data sets to move the action and the insights to the next level. So those heavy investments that energy and utility companies have made in digital transformation gets things started. Systems have been digitized and connected. Data is flowing back to historians or being managed at the edge. These would be systems like your OMS, your GIS, SCADA, DMS, DERMS, AMI, work management systems, billing systems, customer systems. The list, it really goes on and on, as I'm sure many of you are familiar with. From meters to automated substations and intelligent electronic devices along the feeders, we've seen quite an increase in smart equipment that's sending a growing amount of data back to our operating centers worldwide. But the challenge is that a lot of these systems have or really will hit an upper limit on the amount of value that they can extract from non-machine learning systems. And it comes in the form of having too much data to process and not having a strategy for how to handle it. So when you activate these digital assets, we can leverage machine learning to help your employees really take control of your data. But it's not like flipping on a light switch, and there's barriers that need to be addressed, from capabilities to a lack of actionable insights to strategic limitations. Many organizations want to use advanced analytics, but maybe aren't quite sure how to map it to a business objective or a specific implementation plan. And, resources. Data scientists remain one of the most scarce resources across all industries. Job postings for data scientists rose 75% over the last 3 years, and those postings generally take twice as long to fill as any other posting out there. But somehow, we really have to get past all of that, because getting to a point of using the data that everybody's been collecting is really the next step and part of really the necessary progression in the digital transformation journey. It's how we get utilities from where we are today to continue to be profitable, have sustained productivity and value into the future. So it's really important to take the time to develop clear strategies, and you'll hear more on that from Rodney a little bit later, to know what you want to address, to to identify that complex business problem and apply the analytics so that you can really activate the value of those digital investments. So I mentioned cognitive analytics, and we've talked about AI and machine learning, but I wanted to take a couple minutes to make sure we were all on the same page as to what these technologies really are, because the words get thrown around a good bit on a regular basis. So within artificial intelligence, let's start with machine learning. There is unsupervised and supervised machine learning. So these would be different techniques that data scientists would use, or different types of machine learning that your data scientists would use. So unsupervised machine learning uses unlabeled data to discover the relationship between inputs. So in this case, you really wouldn't have a set of what we would describe as labeled events. And a labeled event might be failure data from past historical information. So in this case, the model is really learning relationships between inputs to ultimately identify or predict future events. So think of this as failure detection without necessarily having a clear definition of what that failure looks like when you get started. The model learns what a failure looks like by understanding what normal operation is. So supervised, as you may then guess, has a labeled training data set, and it consists of a set of training examples, or if we kind of continue the example I described earlier, it has actual asset or device failures as an example for the model to learn from. So unlike unsupervised machine learning, in supervised machine learning, the output of the algorithm is actually known. You have input and output data that's ultimately then used to train the algorithm to learn a particular function. So at SparkCognition, we've had some significant success in predicting failures of brand new, never before used critical assets. You know, these devices didn't have failure signatures or events for us to really classify against. In this case, our algorithms actually, they learned what normal operation looks like and could actually identify anomalies before other monitoring systems. So as we look ahead for the energy industry, as the industry invests in a growing number of new assets and develops new strategies, and particularly deploying assets in all sorts of new configurations, unsupervised learning could be a really interesting tool to help you build effective strategies when you don't have that historical events or historical failures to support it. So natural language processing, you'll hear a little bit more from Rodney a little bit later today. You're likely familiar with NLP in your daily life. So NLP is how we're all engaging with Siri, Alexa, or Google Home. Within an organization, NLP might look a little bit differently. So it could be used to better manage the rapidly growing amount of unstructured data that exists in emails, in maintenance logs, in PDFs, in manuals. I mean, there's so many possible ways to extract data from all of that material. But NLP works by analyzing patterns in natural language, and it allows energy companies and utilities to begin to get that right information to the right place at the right time. And it's going to become a bigger challenge to get that information to the right place at the right time. As much as we want to, track information in clear, usable fields that we've kind of codified, the bigger challenge is that 80% of enterprise data is actually unstructured, and it's growing pretty rapidly. So finding ways to leverage NLP to support employees is going to be a big piece of strategy moving forward. And at its core, NLP works by using knowledge extraction to make unstructured data analyzable. So it works by defining classes of knowledge. So as you can see on the slide, a human is annotating interesting parts of a press release. The items would be annotated with date, operator, resource, location, and status. With NLP, the human doesn't have to do this, doesn't have to pull this information out of every press release. It could be automated. And the same thing applies to all of the different examples I provided earlier around maintenance and other operations techniques. In essence, it really allows you to turn words into data that could be analyzed much like a numerical data set. So no matter where you're working, the machine learning process takes a little bit of time, but it's a pretty straightforward approach. And there's really a three-step process that gets us from all of the data sets that you have into an actual optimized predictive model. So first off, the data actually needs to get cleansed and prepared. It's much like you used to hear, you know, garbage in equals garbage out. So the cleansing process is a really key part of getting to an effective model. It could include things like imputing values for missing data points. So next, we have feature extraction, and that's when the most important tags or features are selected or computed based on the predictive modeling problem that's actually being addressed. And then the model trains on the data and iterates many times using various algorithms and approaches until you get to that final optimal model. It's a complicated process. It generally doesn't happen overnight, and there is usually a data scientist involved in this process. But the effort to really create these models, it's worth it in the end. The great thing about machine learning, as I mentioned, is it looks at all the possible variables and features. It finds patterns that, you know, we can't see ourselves. It leverages what you might call multidimensional optimization. Because of all of this analysis and really the explainable nature of the results, the neat thing is it can tell you which features have the most influence on the output, as well as the most influence on prediction accuracy. So you can then take steps to address your operations accordingly. With kind of that insight that you get from the model, you can take action based on the results and ultimately improve decision making. Now, when an optimized model really becomes integrated within an organization or a process, the analytics become scalable, right? It's something that can grow with your organization. And one of the best things is that the performance of these models improve over time. As you expand the data sets and the model ingests more and more information, it continues to learn and to improve the output. And the system can also extract additional insights without interruptions. You know, in essence, it becomes a bit like the old Energizer Bunny commercials. It's working for you even when you're taking a break. And it's become an essential way to amplify the impact of analytics teams moving forward. And if you consider the fact that in the utility industry alone, annual spend on smart grid-related analytics is expected to reach over $3.8 billion globally in the next couple of years, you know, finding ways to amplify that spend will be critical. And speaking of that spend, you know, clearly organizations across the energy industry have had analytics teams for some time, and many energy companies are also equipping those teams with data science tools, techniques, and support to start tackling these challenges. You know, the teams vary, but you could still encounter some challenges when getting them up and running. We talked about some of them before on the availability of data scientists, but it's difficult, and it takes a lot of time to get from kind of that input data to the final model. The skill set is a bit unique and continues to be in high demand. If you're anything like many of the clients we speak with, you probably have a very long list of potential projects and a short timeline to get to those results. And like anything worth doing, right, it takes time and it takes practice to become skilled in data science. But the great thing, so SparkCognition has been around and working on these solutions since 2013. We've been focused on industrial challenges, especially in the energy and utility space. You know, from our perspective, machine learning is mature, it's approachable, and it really solves today's problems. I'd like to play a short video that will kind of give you a perspective on one of our solutions, and we will dive right into the use cases.
Darwin is a machine learning solution that accelerates the development of highly accurate models by automating time-consuming tasks of the data science process. With Darwin, data scientists, analysts, and engineers can rapidly create models by simply selecting the kind of problem they are trying to solve, uploading their dataset, and specifying training parameters. Darwin automatically ingests, cleans, and normalizes data to make it usable. Then it generates and selects appropriate features to begin iterating through thousands of possible model architectures to find the most optimal solution. With support for both supervised and unsupervised training, Darwin can deliver highly accurate results in less time. It also makes models explainable by exposing insights on how these results were achieved. Once models are created, additional datasets can be used to either test or improve model accuracy, automating the model maintenance process. Darwin also includes a Python SDK and a REST API to facilitate the generation, deployment, and maintenance of models when integrating with third-party solutions. Darwin maximizes the value of your data and augments in-house talent by making machine learning accessible and scalable. Darwin, automated model building. Get insights faster.
Okay, so I hope that gave you a perspective of some of our capabilities in assisting your analytics teams. So I'd like to dive into some of the use cases for AI and machine learning next. As we talk about them, please be thinking about some of the complex challenges that you're facing and how AI might be able to help. As I mentioned, these use cases are certainly not all-encompassing. We've selected a few to highlight, so let's dive in. All right, so as we discussed earlier, the energy grid really continues to increase, really seems exponentially in complexity. As of 2 years ago, 70% of the grid's key components were more than 25 years old. So it makes sense that we're really now in the midst of massive asset replacement strategies with all types of new devices and especially power sources. And we also mentioned how consumers are looking to act as producers. So as you're deploying new assets that haven't been on the grid before, and especially in configurations that we haven't seen, they're going to operate differently and they're going to perform differently than we've seen in the past. And being able to predict performance for assets that don't have a history, not only for their energy output, but also predicting or preventing potential failures, fault detection, things like that will be increasingly important. The utility could also have an overall system dashboard that kind of links data from, could be vegetation management, could be outages, customer calls, work orders, to give a visual overview, a display, an insight on where we would need to prioritize investment dollars going forward. With this increasingly complex system of systems, the data sets are enormous, and the value of identifying anomalies or identifying outliers and identifying investment priorities just grows even bigger. So finding those early indicators can eliminate or significantly reduce outages for the customer and provide for a much more proactive maintenance strategy as opposed to a time-based or a reactive maintenance strategy. So I mentioned before, anomaly detection solutions, they're quite mature and they can be easily applied to grid assets. As we look at these AI-based solutions, they consist of 3 pillars, right? You've got all of those data sets that we discussed that you're ingesting, the machine learning models that provide the analytics, and then ultimately, providing these insights with an application wrapper, a nice user interface, so that an SME or a non-technical user, the data scientist isn't the one that's going to be making decisions, right, on what to actually get done on the grid or what strategies need to move forward, but the person, the SME, will be able to see these insights and then make the appropriate decisions. So when you combine these pieces together, it takes that complicated data science and moves it away from the user into a turnkey solution that you can really deploy at scale and improve kind of asset management practices. So as I mentioned, Rodney's going to go into more detail in a couple minutes on the possibilities for human-to-asset or machine interaction. But we're seeing some pretty significant traction with the way that natural language processing can be used to help technicians engage with complex machines and devices. So NLP is able to translate the contextual status in really simple terms for a technician, and it would reduce the amount of time that a tech spends on troubleshooting and repair. So this is really critical today as workforce retirement grows and that wealth of knowledge leaves the workforce with them, or in particular when an existing knowledge base might not apply to new assets. So those technicians and the linemen and women out there, they're a wealth of knowledge, but their insight is often captured in free-form text fields. We've worked with a different client to leverage NLP data from maintenance logs to better inform future maintenance practices, and it resulted in reduced cost, improved asset availability and resilience, and it really protected against knowledge drain as their workforce transformed. You know, from a customer vantage point, we can look to eliminate, again, outages and improve service offerings by identifying trends and reducing those failure trends with improved practices. The evolving grid, so new customer preferences, they present quite the opportunity to connect customers efficiently with renewables. And AI can really be a piece of the puzzle when we're looking to figure out how to implement renewables in new ways. So first, you could use AI to determine the feasibility of a renewables interconnection. You know, for some operators, evaluating an interconnection has months-long backlogs. AI could evaluate power flow scenarios and improve the speed of current interconnection studies fairly significantly. Because renewables and energy storage are dependent on uncontrollable environmental factors, right? They're quite, renewables are quite intermittent and energy storage works very well with them. But the utilities are struggling to balance storage and demand. And as we've seen in other deployments, AI can help forecast demand and balance it with weather events and other system challenges. There's a lot of historical data out there that probably we're not leveraging in some of our forecasting capabilities to help better predict and optimize the amount of energy that needs to be stored and then ultimately distributed. It could also improve market participation in those areas where there's different opportunities for bidding strategies in retail and wholesale markets. And lastly, if we just look at the renewable resources that are out there, it could help operators boost system efficiency through real-time performance analysis, you know, condition-based monitoring, robotics, and inspections. AI is a critical piece of interpreting that data that's gathered through those observations. So, from a customer standpoint, more directly, many organizations are currently conducting demographic analysis of their customer data, and they're learning how to segment their customers using various services for insights. But some really new and innovative approaches exist by integrating external data sets and trends that are available out there, incorporating insights that might be available from other sources and applying machine learning. So imagine a case where using AI and machine learning, you can precisely assess the top factors that are actually driving customer satisfaction or even a net promoter score assignment. And you could take actionable steps to influence their ratings. We could learn if their score and their satisfaction, is it related to how they paid their bill, how long they spent on the website or the app, the price of their bill, an outage that they had that month, a news story that they happened to see, or something completely unrelated to the utility, or really all of it combined. There's ways to leverage those many data sets and extract insights. And when you pull all of those data sets together in a single model, you're in a better position to determine where to focus those customer experience investment dollars. And additionally, it becomes possible to determine what customers might be interested in new products or solutions that you could offer to meet their needs. It becomes a much more customized and personal solution so that the customer feels like they have an individual relationship with you as opposed to you and their millions of other customers out there. And so as energy companies look to develop these new business models based on services, using AI to truly understand the voice of the customer and achieve higher personalization is a really critical way to begin to monetize the data. And finally, resources and people are still a really critical part of the equation due to the immense amounts and complexity of projects, especially as investment dollars move from large power plants to grid investments. And it's pretty risky to have limited staffing, but it's important not to overspend. So using internal and external data, a little similar to the storm predictions that Faye mentioned at the beginning, machine learning can help make sense of events and trends that result in under or overstaffing. You could leverage external data sources like city planning records and real estate records to plan for growth and the associated work orders. It can help model and predict the seasonality of known and unknown events to mitigate impacts to operations. And in the end, that leads to faster service times for customers across any engagement they may have with the utility. So now I'm going to turn it over to Rodney so he can speak a little bit about the exciting work that Duke Energy has been working on.
Thank you, Jessica. My name is Rodney James with Duke Energy. I'm in the Emerging Technologies office, and a little bit about us. We are a R&D shop for Duke Energy. We look at technology about 5, 10, 15 years into the future, look at and evaluate that technology for not only our internal stakeholders, but also for the larger utility as well. And then we develop white papers to inform those groups. A little bit about Duke Energy. We operate in 5 states, North Carolina, South Carolina, Ohio, Kentucky, and Florida. We also have renewable energy in all over the U.S. We have about 52,000 megawatts of generating capacity to serve about 7.4 million customers. So a little bit about natural language processing. For us, this is looking at unstructured data. So for us, that would be a lot of historian data, a lot of our job aids, and a lot of tech manuals and things like that. And then being able to process that with complex questions that would unite all of this information together, and then present those answers and solutions based on supported evidence and the quality of information found. So for this particular project that we worked with SparkCognition on, we wanted to take the small use case of substation transformer maintenance, and we developed 20 questions and answers, using 5 of those questions from a one-line diagram of the circuit. 10 of those questions were from a transformer O&M manual, and then 5 of those were analytics based on Pi data. So what we did is we used Microsoft Excel, and we put that information into an Excel spreadsheet to then be able to have our AI machine process that information to mimic what it would look like if it were on an active database, such as Pi or some other library or historian. We used SparkCognition's deep NLP technology on a Now robot. The reason why we used the Neo robot was because it allowed for programming. It allowed for programming and the deep NLP software to be deployed. We really were thinking of more of an Amazon Echo or an Alexa for a substation. So that's what we had in mind, but it really came out in the use of a robot. So here's a small video of the robot in action.
I'm about to start doing the transformer inspection. What's my first step?
The first step is to do the transformer visual inspection. First, you would need to check the bushings for contamination, oil leaks, oil level, general transformer condition.
What's my second step?
Check the transformer for oil leaks.
The oil level gauge is showing low oil level. When did the alarm come in?
The alarm became active on August 1st, 2017 at 1,100 hours.
Did the transformer have any top oil temperature alarm or hotspot temperature alarm during the same day?
No, it did not.
What was the maximum loading during the same day?
The maximum loading on that day was 25.5 kVA or 68.92%.
What is the third step?
Check the panes, any potential bushing gaps, and lightning arresters.
What was the maximum loading during the same day?
The maximum loading on that day was 25.5 kVA or 68.92%.
What was the max loading on that day?
The maximum loading on that day was 25.5 kVA or 68.92%.
Is there an alarm on the DGA monitor?
No, it did not.
Does the DGA monitor have an alarm?
No, it did not.
Do I need to check anything else on the cooling system?
You need to check the loss of AC alarm by opening the circuit breaker to the control circuit within the transformer. This should send the loss of AC alarm.
Is there anything on the cooling system that could cause this issue?
You need to check the loss of AC alarm by opening the circuit breaker to the control circuit within the transformer. This should send the loss of AC alarm.
You let me know. All right, thank you. So as you can see in that video, here are a couple of things that we learned from the overall project. First, we saw that voice interaction between human and an AI engine is possible and that the quality is improving at a rapid rate. So we are able to, again, take data from disparate systems. We think we can expand this actually to what we would call living systems, but we can take that data, ask certain questions of the data to have the AI engine process those questions and then be able to give us relevant answers. So that means performing data analytics on the given set of data, so where you might have two values in two different cells, processing that data and then giving an answer back, or providing the same answer to an end user given the variety of ways that the same question can be asked by different users. And this would be very important for a substation technician who, or for different substation technicians who would be interacting with this system. So the next place we would like to go is using a Cognibot. So we're investigating the difference between a chatbot, which is what you saw earlier. So we ask questions, we ask questions of the system, of the AI system, and we get an answer back. Something like, what's the current status of the transformer oil level? And then the chatbot responds.
Apparently we're breaking up.
Okay. Can you hear me now? Okay. So again, the chatbot would be, what is the current status of the transformer oil level? And the current status of, and the chatbot would respond on the current status of the transformer oil level is normal. Then, in the next step, we would look at a Cognibot. So based on an AI understanding of the system and the devices in that system, the Cognibot would start the conversation. The current transformer oil level is normal. However, the oil level has been constantly decreasing over the last 2 weeks. At current pace, it will go into a low level state in 3 days. Do you want me to schedule the immediate inspection for potential leak? Technician, please schedule. So this is where the AI actually moves ahead to schedule the unit for evaluation. And with that, I'll return it back to Jessica.
Thanks, Rodney. So for everybody on the phone, hopefully after today you have a better understanding of how artificial intelligence and machine learning really opens doors to an abundant list of actionable use cases. And as you think about what might make a good project to pursue within your area of expertise, remember the following 3 things. Do you have the data? Is it accessible? Is it a complex problem, and will solving it have real business impact? You know, like any endeavor, being clear about your outcomes and defining success is important. As I mentioned, Spark has been in this space since 2013, and we have over 70 different clients across a number of industries, including energy and utilities, so we're excited to help. And lastly, if you already have data sets and want to better understand them, there's really no better time to start. Darwin, the video that we shared, we're actually offering a free 15-day trial of that automated model building platform that technical and non-technical analysts can use to start making predictions from data. So you can check it out at the link on the screen. So thank you for your time today. Rodney and I look forward to your questions.
Thank you, Jessica and Rodney. This has been very thorough and informative. I'm sure audience on the phone appreciates the breakdown of the buzzwords, understand what it actually means in terms of machine learning and artificial intelligence, how that actually relates to the tasks they're looking into, and it's great to see the solution in the demo in action. So this has been really helpful. So the first question from the audience is that in terms of the auto model building, what are some criteria and metrics you use to determine the model is actually modeling accurate results? How do you assess that?
Thanks. So it really is dependent on whether you're using unsupervised or supervised machine learning. So for unsupervised machine learning applications, you're comparing those anomalies and clusters to known events. So you're getting a percentage accuracy based on that comparison. And for supervised machine learning, we compare the results of the model with known outcomes that were provided in the training data set. So in both cases, you are really looking at the ability of the model to catch those events or errors or failures that's available in the training data. So it tends to be a percentage rating for the model.
Great.
Hopefully that answers the question. If not, we can dive in more offline.
Great. And I also want to know a little bit more about the collaboration between SparkCognition and Duke Energy. In terms of the actual deployment process, how did that work, and how long did it take? How much customization is involved in deploying that solution?
So, like I said, we pretty much used the platform of the Neo robot. So that's where we're going to deploy the platform. It took about, if I remember correctly, about a month of work on the SparkCognition side to develop the engine and the call and response, and then it took about another another week or so for us to get the robot and everything set up on our end once SparkCognition was done. Now, again, the idea is that it wouldn't be in the form factor of a robot going forward, but that's pretty much where we started the use cases from.
Fantastic. Another question from the audience is about how AI's different use cases, and one question is that have you seen use cases for distribution planning using AI at utilities?
Yes, so I think the answer is yes. Distribution planning can mean a lot of different pieces. I think we have seen distribution planning as it relates to where's the best place for certain assets, for substation expansions, to identify those opportunities. So yes. Now, I think there are a number of companies out there that are working on larger scale deployments where you would be able to do broad distribution planning for an entire system. And I think that is a great area of opportunity for artificial intelligence moving forward. So yes, we can get some specifics on that as a follow-up as well.
Great. Yeah, and Jessica, you mentioned in your key takeaways that one of the first questions you should ask is that, do you have the data? So to make this process possible, would SparkCognition, as a technology vendor, need additional sensors to generate more data? What is the requirement for the solution to work on your end?
So we have worked with people when they require new sensors, but that isn't a core part of our offering. It's more if that need comes up, we can work with them to understand what the gap might be. Generally, we work with whatever data sets you have available. I mean, we could connect to various historians. They could be CSV files. It could be Excel files. We've done a lot of different formats. So generally most any format of data you have, we can work with. But knowing you have the data and it's accessible and able to be shared, of course, under an NDA with the appropriate, agreement in place, that's the critical first part. And if you have a gap from a sensor standpoint, we can help you identify who might be able to help fill that gap so that we can work on a project moving forward.
Thank you. The next question is for Rodney. So has Duke Energy applied Darwin to a customer experience data set and try to address a specific issue relating to customer experience?
No, we have. No, we have not done this on the customer experience portion yet.
Great. Well, so yes, we are towards the end of the presentation hour here. So we have a few more questions that I think it will need a little bit more follow-up offline. We'll certainly do that. And I do understand that during the presentation, some of the audience members could not view the video, so we'll address that in our follow-up correspondence as well. And and thank you, Jessica. Thank you, Rodney, for your very thorough presentation today. And thank you for sending in questions. And hope you can join us next time for another webinar. And hope you have a great day.